right? If you have like an 2 as your x value and it has 2 different y values, it's not a function. If you have an x as a 2 and it only has one y value, that's a function. You have to make sure, though, that that's how it is for every x value. So let's start looking at practice. Well, just a little bit of examples, actually, and then we'll go to guided practice next. So it says determine, so here are examples. Determine whether or not the following representations are functions. Explain your thinking. So number 1, I see -2 has 7. Do I see -2 anymore? No, so -2 only had one y value. My input only had one output. -1, do I see it anymore? No, so -1 only had one y value. 0, I don't see it anymore. It only had one y value then. 1, just 1. 2, just one y value. So this is a function because each x value had only one y value. And that's the definition of a function, right? So here's what it is. If we had -2 on here again, and it had 5 or something else other than 7, that wouldn't be a function because we had -2 with 2 different values, okay? So basically, if you see that x in the table repeated more than once with that different value, then you know it's not a function. That's how simple these are. You're just making sure there's only one output for every input, one y for every x. Okay, so another example. These are a little tricky and you might want to map them or put them in a table. And I probably would like the table way, but you can also just look. So here's what you have to remember is these are x, y. And I don't know how many times I said label those x, y pairs. I'm like, and that slope formula, you better have a label, you better have a label. Well, guess what? You need to go ahead and label these two to keep it clear. Because look at what it does for you then. You know you're going to go look at all these x values and make sure they don't repeat. So look here, -2, does it repeat on the x's? Uh-oh, it did. -2 is here, and it gives you a 1. -2 is here, and it gives you an 8. That doesn't match the definition of a function. This has 2 different y values for the same x value. This is not a function because -2, I should say this because the x value, -2, had 2 different outputs. So basically, if you see the same x value more than once, it's not a function because it gave you 2 different outputs. That's not allowed. Functions, you can only have one output for every input. This is not because it had 2. Okay? If you can't see these clearly while you're doing them, you could always put it to a table. All right. Let's go to the map and we'll do the graph last because to me the graph is the easiest one or the easiest ones. So here's this map. All right. And I see it goes 0 goes to 5, 1 goes to 5, 2 goes to 5, 3 goes to 5. So think about that real quick. Okay. So we have 0 as an x. Does it only have one y value? It does. Does 1 only have one y value? It does. Does 2 only have one y value? Yes. Does 3? Yes. If this was in a table, we would notice all our x's are different and they all only have one y value. So yes, this is a function. Because each x value has only one output or one y value. So if you put this in a table, it'd be 0, 5, 1, 5, 2, 5, 3, 5. It doesn't matter that they all have the same output number. That can happen. Because think about this, if this was teachers going to classrooms, 4 teachers could go work in one classroom, no problem. We have 2 to 3 teachers in some classrooms all the time. That can happen. What couldn't happen was the opposite. If there was only one teacher trying to go to 4 places, that wouldn't work. But this is saying like 4 people going to one spot. Yeah, that can work. So same thing here. It's functional. There's only one output for every input. And then the last one is the vertical line test. This is going to be covered on the next video just because this video got too long, okay? That one will be covered on video 2.